So the next part on this drawing, or this fire extinguisher that I'm going to draw, is the valve. And the valve on these couple of pictures is located here under the bottom handle. It's behind the gauge. The gauge threads into the valve, and the way that it works is when this piece is, if you pull the pin and this top handle is depressed, it pivots right here like a seesaw, and it pulls up right in here a little brass fitting, which lets the material inside the fire extinguisher get exhausted. This is a picture kind of the end view of this valve, and if you look, you can see that the handle right in here, the lower handle, slides into a couple of notches. And then there are holes that go through this aluminum block in specified spots where there are rivets. I don't see, I'm just scrolling down. So here's another picture of it from the side. It's probably the easiest part on this entire, there's a great picture of it. So again, you can see right here that these couple of notches are pretty critical because the lower handle go right in there. Okay, there are a couple of things on this that you do have to solve, and there's a couple of things that you have to ballpark. So what I'm going to do is start down in the bottom left of this valve. This is something I almost feel like I don't really need to do an entire video on, or I could like fast forward, but I'll do it a point at a time. So I'm going to start in this bottom left corner. This line right here, I'm thinking I'm going to have to do this in 2 videos. This line right here, this dotted line, is symbolizing a imaginary point between here and here, so that this curve is able to be calculated. So I'm going to start from bottom left and just work my way up a line at a time, and I'll do that on my valve layer, I suppose I could do. So I'm going to draw a line starting right here, coming up, and that line is, I can switch my layer. There we go. So I'm going to come up 0.87, and then for measurement B, the measurement is up here. It's 0.338 to the left, 0.338. And then as I come down, I also can't see, if you look in here, measurement C is posted up above, which is 0.550. I think I'm going to run out of space here in a second. Measurement A is, in this part, is like a cleat where it mounts on the wall. Measurement A is 0.20. And coming up, and I can see that is 0.950. And then measurement D, I wasn't able to fit. That says it's 0.720. Now I'm going to get over to the notch, which is, looking in here, it's you can see E and H. The letters E and H note the notch. And if you look up here, you'll see that the notch is E is 0.10 in width and 0.075 in depth. So what I do is I come down 0.075, and then I come over, I can't even remember now, 0.10. 0.10, and then I'm back on to something I can see, which is 0.545. And then point F and point G are the same, so now we're into the point that everything on both sides of the valve is symmetrical. Point F is 0.120, and then to this point right here, which is 0.690. And looking at the top, I don't know why it's not measured, but what I can do is, if I look down the right side, everything now is symmetrical with the exception of that angle. So this is where I'm going to come back over and look at the width of the valve overall, and I'm going to draw that in with a construction line. So I'm going to have to come back to my drawing, wherever that went, and oops, that's not it. That's it. So the width of the valve overall was 1.5. So I'm going to come back to my drawing, and I'm just going to draw a line. That was 1.5. And the other thing I can do while I'm here is I can get this curvature on the bottom by looking again back at my drawing, wherever it was. There it goes. And the curvature to see from this imaginary dotted line, which is the yellow line I just drew, if I go from the midpoint and I go down 0.1 inches, 1/10 of an inch, then that will give me a middle point to snap for my curve. So there's a middle point to snap. And now I can come back to my valve layer and I can get this out of the way right now. Just draw an arc. First click, second click, third click, and that creates the correct geometry for the arc. I'm going to have to use this later because there is a slicing operation to get a curve. This thing curves both ways. So I'm going to have to borrow this later on. And so I'll come back and deal with that. Now, what I'm going to do is that I'm using this line as a mirror line. If I didn't know the distance across the top, what I can do is I can select everything that's transferable. So everything from here on up, I can mirror it right around. MI is the mirror hotkey, if you didn't know it. I can mirror it right around there, and now I can just connect the dots. Okay. Now I'm at a point on this side. Oh, I could have also grabbed this. I forgot that along the way. So I'm at this point now, and this is where there's a point that says calculate. You see where it says solve right here. So above this notch, this is an unknown, there's an unknown flat distance here. We don't know if it's this long or whatever. I'm just going to draw it out into space. And then what I'm going to do is I'm going to draw this at a height that aligns with the bottom of this notch right here. So in this case, I can send this out into space as well, and then just take a construction line. It's horizontal. Place it right here at the bottom of the notch, which is where this is going to line up. And then now I can just draw a line. The calculate part, it's not really a calculation. I just have to include a 45-degree angle like it showed over there. So I'll just give it any old distance. I'll say at 1 angle 45. Oops, so it's not 45. Why isn't it 45? Because it's got to go in this direction. It has to go 45 past 90. So in this case, I'll use the at symbol, 1 angle, and I'll say 135. That has made that 45 in the other direction. And now I just have some trimming to do. I got to get rid of that. And I got to get rid of that and that and that. And then this is it's all connected. That's a goner. And the valve is actually drawn. It's complete. There's a couple of places, and I'm going to stop this almost here in a second, where it says, like right here, you can see that says there's a radius of 0.05. And then down here, at the bottom of that angled portion, there's a radius of 0.025. So in this case, I'm going to use my fillet tool, F space, R space for radius. I'll type in 0.05. And then I come in here, and I'm going to go ahead and click that line, click its adjacent partner, right-click repeat, and click those. Now I'll do the 0.025 one, and that would be here and here. Okay, and the more, and I think putting in fillets, we could even go with fillets that are a hair smaller, like 0.015, something real small. But if you put those in along the way, we know that in machinery or machining manufacturing, we typically don't have really hard unfinished 90-degree edges, and the reason is because they're sharp and we don't want sharp edges. So what I do is, just like I'm doing, I'm going to end this video and I'm going to come back to the final portion, which is the extrusion and the slicing component. But what I am going to do while I'm before I do come back is I'm going to go around and fillet all of these little portions. I might want to undo a couple of these because I think they are kind of sharper corners down in here. So, but anything at least on an outside, like here and here, would be typically filleted. They might have left a hard edge on the inside of that. So go ahead and do those. And I swear when you do render this, it certainly will make the rendering look considerably more realistic. So that's it. And I'll come back with the extrusion piece here in a minute.